Hello, this is problem 10 of a 50-part series of problems from Orgo 2. So let's look at the problem here. How would you use NMR spectroscopy to distinguish between the following compounds? If we look at these two compounds, what we actually see here is that in the first structure, right, we have all of these. The benzene ring is exactly the same as the benzene ring over on the right. However, the actual difference between these two structures is the second fused ring present in the structure, right? So we can actually say here that if you think about these two hydrogens, let me call them A here, right? And then there are two hydrogens, let me just call them B. Okay, now, and we know that there is a plane of symmetry here, because of which HA will have the exact chemical shift as HB. So that's one. Let's check if that is actually going to be true for now our second structure. Now in the second structure, we have these two hydrogens as HAs and then these two hydrogens as HBs. Can we actually check here if HA and HB are actually equivalent? So if we think about it, if I place a plane of symmetry here or even here, right, I'm not really able to break the molecule in half, so I can see here that HA and HB are not equivalent, right? Here HA and HB are equivalent, so they both will give us the same signal. So then there will be one less signal if we actually look at the structure or the NMR of that compound. And of course, if we talk about the splitting pattern for HA, it will show up as a singlet, right? And for HB also will show as a singlet. However, HA here will show as a triplet. The other one will also show as a triplet. However, right, that will also be the difference in how the multiplicity of each peak will show up.